Hey y'all, welcome back. It's me, Ms. V, and today we're going to go ahead and talk about triangle similarity and do a couple of triangle similarity proofs. Before we do that, though, I want to go ahead and do a triangle similarity application question. So if we read this question, it says, on level ground, the base of a tree is 20 feet from the bottom of a 48-foot flagpole. So this right here is my flagpole, and they said that the flagpole was 48 feet, okay? Then it said that the base of your tree was 20 feet from the bottom of your flagpole. So right over here is the bottom of your flagpole. This is the base of your tree. So this distance right here is 20 feet. Okay. Then it says the tree is shorter than the pole. So they're confirming that even though it looks shorter, they're confirming it. Okay. And then at a certain time, their shadows end at the same point, 60 feet from the base of the flagpole. So right over here, this is where their shadows end. And this distance from here to here, since it says from the base of your flagpole, this distance is 60 feet, okay? So now, since I know this whole distance is 60 feet, basically what's going to happen here is I'm going to separate this problem into two smaller triangles, okay? The first triangle is the one with the tree. So this is the one with the tree over here, this triangle. Okay. And again, we're trying to find the height of the tree. So this will be X. We don't know what that is. And then my second triangle is the bigger one. Okay. And this over here now is the flagpole instead, which we know that it's 48 feet. Okay. Boom, boom, boom. And we know this is a right angle here and here. And we have the distance from the very end. This is where the shadow ends. So I guess let me label that point. Shadow end here. Again, right here, this is where the shadow ends. Okay, so we know that this distance for the flagpole to where the shadow ends is 60 feet. Okay, now we're going to go ahead and find this distance here. I know that to get from the base of the flagpole to the tree takes 20 feet. So to find the rest of this distance, all I really have to do is 60 minus 20. So now I know that this distance here is 40 feet, okay? From here to here, because remember, the whole thing is 60. If this part is 20, then the rest of it has to be 40, because 40 plus 20 gives us 60. So now here we have two similar triangles, and we can set up a proportion to solve for X, okay? So remember that the scale factor should be the same for both of them. So for example, if I divide 40 by X, whatever X is, it should equal 60 divided by 48 because they're similar triangles. So 40 over X should equal 60 over 48. Okay. Now here we have a proportion. So we're going to go ahead and cross multiply. Multiply 40 times 48 and 60 times X. So now 60X equals 40 times 48. So 60X equals 40 times 48, which is, let's see, 40, plugging it into my calculator, is 1920. Okay. And now from here, since we're trying to solve for X, we're going to go ahead and divide both sides by 60. And I'm going to go ahead and move this over here. Okay, so I'm going to divide by 60 and by 60. 1920 divided by 60 equals 32, which means X equals 32. So the height of our tree is 32 feet. Tree is 32 feet tall. Okay, so this is basically an application question for dilations and for proportions, because essentially that's all a dilation is. It's proportions that you continue multiplying by, okay? Now over here we have a proof, okay? So I've talked about proofs before on this channel, and like I said, they can be a little bit of, they could be a little bit tricky if you're not paying attention. or if it's your first time doing them, but I'm going to go ahead and review. So remember, for your proof, you always start off with the given information, which in this case, we're saying that GK is parallel to HJ. So if I look here on the diagram, we're using this diagram over here. They're saying that GK and HJ are parallel. Then from here, they give us the next piece of information, which is that angle IGK and IHJ are congruent because they're corresponding angles, okay? If you were to extend these two parallel lines, right, then you would have this transversal cutting across it, and then these two angles are in the same exact spot, but one is shifted upwards, so those are corresponding angles. And now over here, they give us our next statement, which is that GIK, which is this angle up here, is congruent to HIJ. So GIK and HIJ are congruent because they're the same exact angle, which means that you would say that they're congruent by the reflexive property. Okay. So whenever you say something is congruent to itself, that's our reflexive property. So now finally, by angle, triangle, similarity, here is the first angle that the triangles have in common. Here's the second one. This is the small triangle. This is the big one. We can say now that triangle GIK is similar to triangle HIJ. Okay. Same thing for the next proof here. I'm going to go ahead and fill in the information that we already started with. So we know GK is parallel to HJ. We know that those two angles were congruent because of the reflexive property. Okay, this is basically the same proof. I just added one more step here. And now finally, we know that triangle GIK is similar. GIK is similar to triangle HIJ. Okay. And in this proof, I know it doesn't say what to prove on here, but in this proof, we were trying to prove that GI over HI was equal to IK over IJ. Okay. So GI is this angle, this long side right here, that's GI. HI is this green side right over here, okay? So remember, since we already said that the big triangle, GIK, and the little one were similar, then if I divide these two sides, which are the matching sides or the corresponding sides, I should get the same exact proportion as me dividing this long side IK by the short side IJ, which is true because we can say that corresponding sides of similar triangles are proportional. So then GI over HI is definitely going to equal IK over IJ. Okay. Last but not least, we already have these two triangles that are similar. Remember, go ahead and match the sides. AB matches with EF. And BC matches with FG. So again, we can go ahead and set up a proportion. AB over EF should equal BC over FG. And we already have these sides. AB is 21, EF is X, BC is 6, FG is 4. And we're going to go ahead and cross multiply. So that 6x equals 21 times 4. So 6x equals 84. Divide both sides by 6. So that x equals 14. X equals 14, okay? And they want us to state the scale factor. So remember, to state the scale factor, just divide. So we can go ahead and take the division of 6 over 4. Okay. which is, well, actually in this case, since ABC is similar to EFG, that means EFG was after. So you would have to do 4 divided by 6 to get the scale factor because it got smaller. So this is 2/3. Okay. So this is our pre-image basically. And this is our image. So if you are a little bit confused about what I just said there, go ahead and take a look at the video where I talk about determining the scale factor. To determine the scale factor, you divide your image by your pre-image. So 4 divided by 6 here, okay? As always, if you guys enjoyed this video, go ahead and give it a like and share it with your friends who are also taking geometry. And please subscribe to my channel and go ahead and comment on my videos so I can help you guys out as much as I can. Thank you so much for all your love and support, and I will see y'all in my next video. Bye.